cases today, and then we'll close this LangGraph, okay? Because I give LangGraph more weightage over other agentic framework, okay? Because it's industry specific, and when you have this LangGraph in your resume, it has high weightage, okay? Because now it's more of high weightage. I would say this agentic AI framework is LangGraph, okay? So if you see the use case that I'll talk. So it says economic intelligence agent. So we'll work on this economic intelligence agent. Also, there is a code. I will be explaining and executing it and how we have designed this solution end to end. We will discuss it, okay? And how come this LangGraph is using here, okay? So LangGraph that connects macro data to market impact, and the questions that we will put in into this agentic AI framework is how does inflation affect technology stocks? Okay, so there is a two terms, inflation and stocks. So how they are affecting to each other. So you might have understanding of this correlation causations, right, in your data science. So we'll see that if you increase the inflations, right, so how someone looking for some stocks, right, they're gonna buy, hold, or sell. So how it typically affects our decision. So whether we can replace manual effort as and you can create some kind of a decision engines. So economic intelligence agent will work as a decision engines, right? So we are eliminating the effort of a human and bringing one agent back so that it can decide to which stocks someone has to invest in if there are some sort of inflations up and down. Okay. So this is what we are trying to achieve today. And there are a few more use cases. We will discuss it. Okay. But there is one diagram. Okay. So because what I see, okay, there is a eraser or what? Mm, clear all my drawings. Clear all drawings. Okay, isn't it? Okay, let it be. So can you see there is something called embeddings? It is written, right? Can you see, right?
Yes.
Yeah. So these concepts are because why I'm trying to explain this thing is, for example, if you work on any of the retrieval augmented generation use cases, you must understand the embeddings and all logics. Whenever you try to interact with any of the LLMs, the base is again the embeddings and how embeddings typically works. That is something that we need to understand. So, I mean, so as per the definitions, okay. So when you say that how we are going to define it, okay. For example, embeddings are nothing but it's numerical vectors and how tokens are being represented. So what is tokens? It's like a word or a smaller than a word is called tokens. But at a high level, if you have to understand what is tokens, for example, in a MS Word, let's say you have 20 or 200 characters in a one document. So we'll treat those 200 character as the tokens. Okay. Minimum tokens would be 200. Okay. So it's a word or a smaller than a word is called tokens. Okay. But on the right side, if you see, but how these are getting converted into embeddings. So let's say dog, cat, and car is there. Okay. In your documents. So they gets converted into some vectors. So vectors are nothing but a numerical representation of numbers. So if you see dog is being represented as 0.82, comma 0.14 and minus 0.28 and dot dot dot. So there are different, it's not a three dimensions, but if you see, there are a lot of dimensions. Either it could be 128, 256, 512, 768, 1024, 1536, 3072. So in interview, they may ask you that the dimensions of these vectors. So you must know that the how many vectors you have created for this, the dimensions that you have taken up, whether it's a 512 or 256. And normally, what is the industry that they converts into vectors, which dimensions they typically pick up, whether it's a 512 or 256. Okay. But again, when you create embeddings, there is something called in the third point. We have something called semantic space. So whatever you have converted into vectors, this will be plotted into vector space. So high dimensionals. If you see here, they are able to, because there are three features, let's say. So it's in three dimensions, but there are more number of features. So the number of features would be the number of dimensions here. Okay. But here they are able to give you into 3D so that you can visualize it. Okay. Sometimes the human can interpret two dimensions, but if you have a three dimensions, it's very difficult for us to interpret it, right? So that is why this, the natural language processing. Other day I was just talking how these words are being mapped in a vector space. Okay. So when you say vector space, there is also a word called semantic space. Semantic means it will cover their meanings. Okay. For example, if you see this one, dog, cat, tiger, and lions. Tiger and lions are very closed in this vector space. Dog and cat are very close in a vector space. They are placed almost together. But car and aeroplanes are much, further. It's too far. Even from the tiger, even from the cat, even from the plane. But if you see dog, cat, lion, and everything, it's somehow very much closer because somehow they are falling under animal kingdom. Okay. So this is how this, whenever you have, let's say your RAG data or any of the data fed into the LLM, internally they try to break tokens into vectors and then they represent into this vector space or semantic space, and then they store it into something called a vector database. So why we require a vector database? Because to store these vectors, to store those embeddings, because these are in numbers, we cannot store in some of this structure language, you can say, in that I would say traditional, whatever we have SQL based database, we cannot. But we need some kind of a vector storage. For example, if we have some Chroma DB, Milverse, there are different vector database where we typically store those numbers, embeddings. That is why you need this, vector storage. For example, in Azure, we have something called Azure AI Search. There we store embeddings. Why we store embeddings? Because we need to capture the meanings, need to capture the relationship, need to capture the reasoning, enable context and understanding. Because what we expect from LLM, because when we put a prompt, we expect that it returns some of the, the reasonable reasonings and contextual aware answers. How come it is coming? Because it is coming from the embeddings, whatever we have stored in the vector storage. So in the retrieval augmented generations, there is something called RAG. The retrieval part is the something which embeddings typically does, because you have to retrieve it from vector storage. Okay. Because if you pass any prompt to your LLM, it will retrieve it from your vector storage, the contextually relevant informations. Okay. That is why these embeddings, vector storage, are much important. Okay. Now coming to this fourth point, we have something called similar meaning equal to similar vector positions. If you see tiger and lion, they are two different animals, but somehow very much closer in terms of a traits, similarity, right? So that is why the meanings on the has the same meanings, similar meanings. That is why they are placed in a vector space very close to each other. Okay. And the fifth point, if you see, we have how they are trying to bring those, you can say the sentences, the words together, how they placing in a vector space. For example, if you have a king, queen, man, and woman. So if you see, can we map woman with the queen, man with the king? Yes, because they are similar, right? So that is why they are very much closer. Okay. Sixth point, if you see, whenever we have any sentence, right, in a PDF or doc, it gets converted into tokens. Tokens will be converted into vectors, and vectors will be represented in a vector space. Then it will represent our semantic meaning. Because for the RAG applications or for any LLM application, AI agent or agentic AI, we need semantic informations back. We do not want, word to word match, exact word match, right? It's not possible, because if you work on exact match, we will not get enough informations back from any of the systems. Okay. But if we are building any of the applications which are capturing the semantic informations, our task is done. Because if you see in any of the AI virtual assistants, they give you a response which are semantically or contextually relevant informations, which are coming from the retrieval part, which is again vector storage or vector database. Okay, got it? Any questions so far? Anyone?
No, so
Okay. Now, so words gets converted to vectors, and vectors store the contextual informations at a high level. Try to understand. Okay. So embedding convert language into math so that AI can understand, compare, and reason about the meanings. This is entire your takeaway. Okay. So what should I do? Let me clear all drawings. Escape or cross it. Now there is one more, a graphical representation. We would say we have something called self-attention. Okay, so what is attention mechanism? Okay, so on and off, you might have, heard of this term called self-attention or attention mechanism. So it is coming from the transformer model. So the backbone of any of the LLM that you see, any of the chatbot, is the transformer model. So it is the revolution, because if you go with one of the traditional, AI ML, you might have heard of something called RNN, CNN, LSTM. They do not have this self-attention mechanism, but this transformer model has this self-attention mechanism. So any LLM that you see are built on top of transformers, and transformer has this a mechanism called self-attention. So in interview, people may ask you, can you explain transformer model? So they expect you to use this self-attention word. And if you are able to explain this self-attention mechanism, I think you are good to go. Okay. So what is a self-attention? Okay. So this attention determines which word are the most important for understanding a tokens. Tokens means a word or smaller than a word is called tokens. Okay. And this attention mechanism will let you know that how we are going to understand a tokens, which are very much important too. Okay. Now, when you go to the point number 2, there is a one sentence. The cat sat on the mat because it was tired. So if you see what it is referring to, it is referring to cat. Okay. So also these are given some numbers, because this will gets converted into some vector format. Okay. So if you go in the third point, attention from it we need, because it will capture the meaning, because the next sentence, because the cat sat on the mat because it was tired, it should be cat was tired. That is why they sat on the mat because the cat was tired. So if you see this query it very closely mapped with cat, then sat mat because was and tired. The 50% it is referring to cat. Why? Because of the attention mechanism. Okay. Also, if you go with this attention heat map, it's like rows and columns, and you'll see that the how each row tokens attends to the column tokens. Okay. So if you see it, 50% referring to cat. Okay. So that is why we say that this token it is referring to cat due to this attention mechanism, because attention mechanism will give you the idea that how to predict the next tokens. Okay. If attention mechanism is not there in any of the LLM, your LLM or your AI systems will not predict the next token if there is a no attention mechanism. Okay. Because for predicting the next token, you must have attention mechanism implemented. Okay. And how you are going to implement it? You will implement it to transformer model. Okay. Now, why attention matters? Because it focuses on relevant words, puts more focus on most useful informations because it is referring to cat here because it's the most useful. Also, it understands the relationship. Why we need attention? Because it also captures the cement of that. Because if I say it doesn't make any sense. Okay, but it captures cat. Okay. Also, this attention mechanism can handle variable context. They can also work on different sentences because this is the single sentence. Just imagine if your documents has, let's say, 1 lakh of sentences. How they're going to understand the syntax, semantics, if I have some relationships. Okay. So this also attention mechanism is gonna handle the context. Okay. And it will help us to improve the reasonings at the end of the day. What is that is the art task. Okay. Again, if you go with the this number sixth point, if we have some of the ambiguity, okay, so how we are going to solve it. Okay. So in this case, if you see this one, Alice gave Sarah her book. Okay. Who? So Alice. Okay. So if you have some of the ambiguity, it is the attention mechanism that gives you the bifurcations, that gives you the weightage. Okay. So this is how this attention mechanisms are solving the hallucinations as well inside your any of the RAG or agentic AI solutions. Okay. Within the systems that we typically create. Okay. Now we have a point number 7. Okay. So tokens, text gets converted into tokens, then it gets converted into some vectors. Then attention mechanism is nothing but it has some keys. Okay. And then it improves some weights because if you see there are weightages, 50%, 10%, these are nothing but weightages. Okay. So this is how typically works. This is the typical maths of attention mechanism. And where we are going to use this attention mechanism is LLM, okay, machine translation, summarizations, code generations, question answering. So whenever you have something where we have to predict the next token. So first one, if you see LLMs, where we use LLMs, if you see, you give a prompt and then some responses comes. So responses is nothing but it's a collection of next tokens. Okay. So that is why the first point LLM. Due to this self-attention mechanism, you are able to get the next tokens predicted. Second one is machine translation. So machine translations also works on transformer model. Having this self-attention mechanism will help in predicting the next tokens. Summarization is again creating a new content. Whenever we have a new content generations, we'll have something that we are doing is next token predictions. Code generation is again next token predictions, and question answer is again. Okay. So these all are the way where we will use this self-attention mechanism. It's part of transformer. And what makes transformer robust is self-attention mechanism. Has ability to predict the next tokens and map it together. Okay. Have the ability to solve the ambiguity. Okay. It captures the meaning, syntax, semantics, and also handles the variable context. That is why it may yeah most powerful thing in this 22nd century or 21st century, whatever you call it, is transformer. Okay. Without transformer concepts, LLM will not be feasible. Okay. Any questions so far? Anyone
Can
has
you
any question?
please explain
Yeah,
the
yeah.
technical portion ones, technical notes which is written?
Which one? Technical notes, where it is written?
Sir, in the bottom left corner.
Multi-head, this one you are saying?
Yes, sir.
Yeah, okay. So variants of attention you are saying?
Yes, sir.
Okay, technical notes over this one. Technical, okay, okay, got it. Technical notes are nothing but these are mathematical way of self attention. So attention equal to soft max, soft max. So this is in neural network. If you see how they are going to create this at the end, if you see the neural network, there is summation and there is a soft max layer, that is a decision layer, typically predictions. So this is the formula. Okay, q kt and that formula and the v. Okay, so this is also used as the transformer is nothing but it's a neural network. So this is the formula of neural network at output layer. So softmax is used there. Okay. For you might have seen there is something called gradient boostings. Okay. So these are the things that are being used. So it's just a maths how they are calculating and giving the weightage. Okay. So the word weightage was there somewhere. Okay. The weightage was somewhere was there. Okay, so it gives the weightage. So how come the weightage is being given using this formula? Okay, so this is how they are able to give the weightage. And also if you see, there is something called projections of embeddings. The values are learned, means how they will learn the value from the previous values, because it is mapped to cat. How they are learning from the previous values, so they are capturing q into k query. So query is what the cat sat on the mat, because and the key, it will assign the key. For example, cat has some keys, it will assign a key because it's a key. For attention mechanism, it is a key, but it is a query because they don't know. It is a query. How? Because they don't know what would be the next part. So it is mapped to cat, sat, mat, and all these things, and we are calling as a key. Now, through this attention formula, every key will be assigned some weightage. So now this cat key has assigned 50%. How? Through this formula. That is why key is mapped to cat now. Got it? Subhangi, I think. Yeah.
Yes, sir. Thank you.
Okay. Any more questions? And there are also variant of this attention. So read it out: multi-attentions, cross attention, mask attentions, sparse attentions. These are the attention mechanism. Okay. So depending on are you, it will be used. This multi-head, cross attentions and everything. Okay. So, for example, if it is image, if it is a video, okay, if it is audio, your attention mechanism will change. But when you have a text to text, we rely on this self attention mechanism. Okay, got it? Now coming to this LangGraph, uh, other day we were discussing about this LangGraph, but this pictorial representation will give us more clarity, and then we'll jump to the use case. Okay. So let me set the context and tone here. So LangGraph, when we say LangGraph, so Again, it's a framework. Okay. And it is saying stateful multi-actor AI applications with LLM. Okay. These things that you have to understand. It is saying, let me go here. Am I able to select something or not? Let me select one. This is saying stateful. Okay. Just remember it. I'll explain what is stateful. So whenever you want memory driven applications, memory means, for example, if you're asking Chat GPT some questions, okay? Let's say you say that, okay, I have invested 1,000 in some stocks or something. Let's say today you have asked. After 3 days, if you are asking that I just want to invest in this XYZ stocks, they will remember your previous conversations. They will say that other day you were saying, I have invested 1,000 rupees in some X stocks. So I'll prefer you to do this because they are capturing your previous state. Previous state means conversations. It's a memory. So whenever they have the memory and whenever you want to implement a memory to any of the agentic AI applications, better to go with this LangGraph. Why industry is adopting this LangGraph? Because it has a stateful framework already inbuilt in it. So give us a framework where we can implement state. Okay. So the agentic AI systems will have those states. State means nothing but the memory. Okay. So now let me directly jump to this state. So what it says, state is the memory shared between the nodes. Okay. So in the Lang graph, what we have typically node. Okay. Node is nothing but the something we call it as an executor. Node will, execute. Okay. For example, if you want to search documents, call API, generate a response. These are the nodes. But edges are what other day I was just talking about. They are the boss. They will give us, a confirmation that, okay, you have to do this and that. So it's kind of create a connections between those nodes. Okay, for example, searching documents is one node and generate answer is one node. But this is edge. It is giving us the directions that first you have to search the document and then you have to generate the answers. So edge is deciding. Okay. But the state is, for example, where is my order? And there is a order ID and status is in transit. This is coming from our database. So if you are storing those conversations in a database, so that will serve as a state for us. For example, if I am building one applications where memory is required, so I'll pick up, for example, Cosmos DB in Azure. Okay, let's say Chroma DB in, let's say, in open source. I need one of the database where I can store those conversations. So as I'm talking about this, let's say in the Azure cloud, we have a Cosmos DB. It's a semi-structured database where we can store those conversations. Okay. And there is something called conditional routing. Okay. So you have to choose it that whether should, if we get an order, should I return it or, if there are further questions. Okay. So this is how typically, this Lang graph works. If you come to the, the previous, I would say, this diagram, this is customer support agent. Okay. And it is asking, where is my order? Let's say you have created one agentic AI systems and you're asking, where is my order, right? So first it will understand the intent that this guy is asking about the order. Okay. So once your agentic AI systems understand the intent, then it will route to the database. This is again a tool calling. It will reach out to the tool and they will see that whether this order number, let's say 1 2 3 4 5, is there in the database or not. They say yes, and then it will return that, okay, it will return the status, fine, it is there. Let's say if it is not there, okay, then again you have to ask, let's say this guy hasn't provided order ID. They will provide this order ID and then it will check again. Okay, this is routing. So this is a non-linear flow. Other day we were talking about the linear flow. Linear flow means we are asking our questions, it will go to the LLM, it will give you the response. This is called a linear flow. But what if there are different ifs and ifs? If you see, there are the multi-term here. Okay. They are also checking that if order is there, we have to update the status as a finish. If it is not, check it again and get back the informations to the user that, okay, can you provide me the order ID so that I can check it again. So here involved a lot of ifs, a lot of non-linearity. Okay, that is why LangGraph is the first choice for the people who wants to bring memory so that it can, store those previous historical conversations. Okay, the beauty of this LangGraph is again the conditional routing. Okay, AI can choose what to do next because these all parts, if something happens, our LLM can decide what to do. Okay, because they can interpret it. So we are giving the AI agent an autonomy to decide if something happens which are not in their memory, right? They can also decide the way we decide, right? The human decides. Okay, now again, as I was just talking about this linear flow, so LangChain is a linear flow, right? So you have some input, for example, input is a prompt here, input is a prompt, and tool is nothing but this is LLM. Okay, this is LLM. And answers we get a response. It's a linear flow. I mean, if you're asking that what is the capital of India, it's again linear flow. It checks back through the LLM and get back a response back, right? But when you have something where we need some kind of iterations, some kind of a logical thinkings, if and words, some time of double if and else or something, right? If it is like a non-linear flow, complex workflows, right? In that case, we need this LangGraph. For example, decisions, then it decides whether I should go by this path A or path B, and then it takes a decisions. So if you have something like this, where we have some of the complex decision-based workflows and some of the memory involved in it, because again you have to check the informations in the memory whether I should take this path A or path B, and it will be decided by the memory means again it is a database. Whatever you have is stored in your previous conversations, it will pick up from there. Okay, and then it will decide. So if you see, a lot of complexity is involved. So other day someone was asking that when to use Crew AI and when to use LangGraph. So once you have this complex workflows, in that case, better to go with your LangGraph, where you see that the systems will be more complex. Crew AI, if you have a linear flow and multi-agent, fine. But if you see that in near future, there won't be any complex or memory part will be added. In that case, better to go with this, Crew AI. But if you have a production grade where you have a doubt of, people may scale and add few tools, things will be more complex. In that case, you have to go with this LangGraph. Now, the beauty of this, I would say this screenshot is that there is some analogous to this real world. So how we are going to, again, it's one of the finest examples. So where we are saying these nodes are check-in, security and boardings. Okay, these are the nodes. So whenever you visit airport, we do check-in, we have some security clearance, and then you board, right? So these are nothing but nodes, a task, I would say. Edges are that paths between them from check-in to security, from security to boarding. So this will be your edges. Okay. Now state is that your ticket and passbook information. It is again a data driven. It's coming from somewhere in the database. Okay. And the LangGraph orchestrator. So the complete airport process flow. So entire process we call it as a Lang. It will be again through this LangGraph only. Okay. So how nodes, edges, and state will talk to each other? We need a one orchestrator. And here this orchestrator is LangGraph. Got it? So, I mean, it will add the entire path. It will add an orchestrator. So when we say agentic AI framework, we are talking about the orchestrator. So Crew AI, LangGraph, semantic kernel, autogen, whatever we are covering is nothing but orchestrator. They will orchestrate. They will let nodes, edges, and state work within their supervisions, right? So if someone asks you what is orchestrator, jump on to give the answer of agentic AI framework. They are asking you to tell few of the agentic AI framework. Okay. Any questions so far? Anyone? Okay. So now coming to when to use LangGraph. If you have AI agent, if you are building AI agent, if you have some multi-steps workflows, the complex workflows, if you have to take some complex decisions you are not sure of, and you want less interventions of humans. Okay, if you have something long running processes, okay, if you have some multi tools talking to each other, right? So in that case you have to work with this LangGraph. So whenever you work on any capstone project, if you see these things are coming somewhere, for example, if you're working on multi-step workflows, or you're building a systems where there are multiple tool calling, okay? So jump on to use this LangGraph. So this is a classical case of LangGraph, okay? So this will give you an entire clue that which framework you have to use. Okay, every single framework can be used for each and every use cases, but some of the use cases where they are apt for, LangGraph is apt for, right? So this is how we can use it. Okay. Now, okay. So what should I clear my drawings? Okay, I'm able to clear it. Let's see if I can move to the next slide. Anyone has any questions you can ask. Okay, no issues. Now, as we are working on the use cases, okay, LangGraph. So now I think you have this concept clear. So again, let me revisit to this LangGraph, okay, this use case. So here we are trying to create an agent, intelligent agent that will help us to understand that how inflation affect the technology stocks. Let's say this is the one questions, but again, you can put the different questions also. Okay. So, I mean, how inflation is going to affect this technology stocks. So it is again some kind of actions that we are talking about. Okay. So if I go down, so what we are trying to solve. Okay. So the problem you are solving is, I mean, CPI and rate prints are hard to connect to the real portfolios. So it will coming from your tools. So don't worry about the finance and everything. Just go by whatever is written here. I will explain the architecture as well. Okay. If you are not from the financial background. There are some missing links that we are solving here, that how data points transmit into sector performance. Okay. And the goal that we are trying to solve is we are trying to explain a concepts where latest data and trace it to the technology stocks. It means, let me pull up this drawings. So this data traces, it will decide which stocks to pick up. Okay. So these are the something that we are trying to solve, and the audience here who are gonna use our AI agent is investors and analysts who wants to have this macro context, not just numbers. They also want the minute informations about this technology stocks through this latest data and traces, and it will be helpful for analysts and investors. Okay, this is what we are trying to solve. Okay. Now, let me cross it. Okay. cross. And what answers we are trying to get? So we are saying explain the impact of rising interest rates on technology stocks. The concepts we are going to explain. Okay. The data we are pulling the data of CPI and inflation. So again, if you see this data pulling, from where we get this data and this data, these are two tools because our LLM doesn't know the information of this spread and CPI inflation. Anyone has any questions? Okay. Then we have something called transmissions. So we are going to connect this macro to live tech sector performance and output. We are going to get some structured output. Okay. So, I mean, just understand this data part because in the systems that we are going to explain in the code and everything that I'll show has two tool calling. One from federal funds rate from Fred and second from the CPI. Okay, it's again the inflation, one of the indicator of inflation. Okay, and if you increase the inflations, unemployment decreases. This is again a weird case. Okay, this is again a weird case. If you increase the inflation, unemployment decrease. Okay. So I remember that I have created one project. So this was one of the project, and even I was just confused that how much, if you increase the inflation, how unemployment will decrease. This is weird for me, but these things happens in your, this economics. Okay. So now, let me just cross all the drawings, come to the next screen. So here again, this linear flow, we have this inflation rates and knowledge and reports. Okay. So we'll see this one. And this is the system architecture. Okay. So if you see this system architecture, inflation part that we are working on. So we'll put these questions in natural language. And the LangGraph had some of the state, how they will create this because these are the nodes and edges. So inflations, how we are going to capture through this freight tool, rates through freight tool, knowledge through Wikipedia and Yahoo Finance, resolve and report through this LLM, whatever LLM we have. And these are the tools. So whenever you see the tools, these are the nodes. This LLM is again a nodes. Okay. This is how it works. And then whatever informations it is capturing, if you see every node reads, so these all are the nodes and it will store information in type directory. Okay. And then we'll get the information. Okay. This is how the architecture is. Okay. So the tool that we were talking about, LLM is a tool there. Freight, that is a tool. Freight, this is, and again the API is this Freight. I'll show you. The Wikipedia and Yahoo Finance and the LLM. So all are the tools. So whenever you work on any of the agentic AI systems, just try to have the classifications, segregations, and listing out of the tools. Okay, and try to map it with the nodes first. The resolve is a node. They will use this LLM tool because they have to pick up these core economic concepts. Inflation is one of the node. They will pick up this freight tool API and will capture this inflation's informations. Rate is also federal funds report series will be captured through this freight tool. Okay. And the nodes they are responsible for is the rates. Again, for the knowledge nodes, they have this Wikipedia tool. Why we need this Wikipedia tool? Because it will capture this sector-wise informations. And the report ultimately, the last that we have to generate some of the reports using these nodes and tools working together, we'll get some of the intelligent report, which should be a structured format, right? So these are the tools that we will be using in this agentic AI LangGraph orchestrator applications. Okay, got it? Any questions, anybody? Everybody is silent. Yeah. Hmm. So now let me share the code. Okay. So let's have the discussion on the code. Everybody is silent, eh? So silent on Saturday. Then graph, this one. Okay. Let's see. Let me share my screen, entire screen, so that it can. Can you see my entire screen, right?
Yes, sir.
Yes, sir.
Nobody had any questions, huh? It's very strange. Everybody is understanding. It's very strange for me, eh? Okay. So we have this code. Okay. So this code is similar to other one that we have discussed, so that will not have to put in more efforts to. But let me, okay. So if you see this, the structure of this code. So whenever you see any code, we have something called requirement.txt. So let me directly go to this requirement.txt. And what all we are using is, these all things we are using. Okay. And these things, for example, Yahoo Finance, Wikipedia, these are the two tools. Okay. Now we have something called, if you go here, there's something called environmental variable that I told you to look into that. Okay. So it will give you that what all they have used. For example, freight API. What is this? Even I don't know, even you don't know, right? So we'll go and hit this freight to this. Okay. I'm just sharing you. Let me share where yeah, okay. People are here. Just open it, okay? So if you go this thread, this one I think it's open for me, but let me again open it for you people. Where I very scary. Let's say, let me open it here. Should I? Okay. Control V, okay, and just open it. So if you open this one, the screen, you'll see Freight. This is uh, Federal Reserve Bank, okay, and you'll get some APIs, okay, because we need to use it as a tool, okay. So if you see this one, just request, if you see request or view your API, you have to create a APIs. Maybe your screen would be different. So something like that, you will get it. So this is the API, okay. So just explore it and you get an API for this Federal Reserve Bank, these APIs, okay. So this is again a tool that it is saying the Fred APIs. If I click it here, it says idle for anyone who is interested to retrieve observations of all series on the release in a bulk and obtain an entire history or something. So whatever you want to use, it is giving us an information. So these are all the categories also in the API. If you can check with, there are different economic data. If people are working on time series data, you can use this tool. Okay. So yeah, there are a lot of tags and everything that we can explore. Okay. Let's say if I go with this economic data series, let me just explore it. So you get some data example JSON format, have some of the parameters of the APIs. Okay. If I go down, it says get some economic data series. An example is something like this. Okay. If we go down, this is XML. This is again your API endpoint, I would say. The response you will get like this. JSON format is this. This is again a key value format. So whenever you run it, this is again an API endpoint and you'll get some output like this. Okay. So these are more important, and just I request you to explore these parts because it's very interesting. Okay. That is why I had used few of the tools that are not common, but but you can explode at the same time. Okay? So if I go to the coding part, okay, so the freight part that we have seen, again the Groq API. Okay, so I mean, I'm using my own for a lot of time. So possible that might exhaust. But how you have to obtain it? Go to the Groq and create the APIs. Okay, it's a very simple one. Okay, now coming to this app.py, this is the entry point. Okay, so if you go this app.py, okay, so let me just first run it and then we'll explain. I think that will work. Let me check if the APIs are working or not, because I doubt. We have used multiple times, right? If it works, then we are fortunate. Otherwise, we have to change the API. Okay, app.py, right. So let's see if our API is working or not. Otherwise, I'll change. Okay. So let's wait. Yeah, it is working. We are fortunate and lucky on Saturday. Okay. So now, how? Let's see the response. Okay, first. The questions we have put into this AI agent is that explain the impact of rising interest rate on technology stocks. Okay. So the concept uses interest rate and it has given these economic reports. So let's read it and then I'll explain the code. Okay. So first it is saying the rising interest rate, if interest rate rises, then how it is going to impact the technology stocks. People do buy different stocks. For example, healthcare stocks, technology stocks, right? Are related to different, verticals, different domains, right? But how, let's say if interest rate is increasing, whether people gonna buy these technology stocks or not. So the reports our AI agent gives us this report back. It is saying interest rates are the cost of borrowing money. They influence how much it costs for the companies and individuals to borrow. When interest rates rise, it becomes more expensive to borrow, which can impact various sectors, including technology stocks. So this is one report they have given to us, kind of observations. And how they are giving us, the two tools are there. This is not coming from the Groq LLM. It is coming from the two tools that is used, the Freight one and the Yahoo Finance, whatever we have seen it, with the help of this Groq LLM. So whatever informations they have fetched through these tools, they have collected it and they have passed it to the LLM, Groq LLM. And then we are getting this human-like response. Okay, got it? And also the second point it is saying the latest macro data source. It is again coming from the tool. The latest data indicator indicates the inflation as measured as consumer price index has been steadily increasing, which the most recent reading at this is the CPI index or something. Meanwhile, the federal funds rates, which is the interest rate at depository institutions, lend and borrow money, has been relatively stable at around, this is some percentage or something. Okay. So these observations that we see is coming from those two tools, passing these informations to LLM. Got it? And this is how we are getting the informations back and we are calling it as an economic intelligence agent. Now let me explain the code here. Now we have this app.py. So if you see this app.py, we have this input, this systems input. If you hover it, it is a module. It is a Python module. if you see this graph, this is again a module. This is coming from the LangGraph. And this is a variable. Okay. Now we have a definitions which in the main. Okay. So if you see this one, okay, this is a main functions, and what it will hold, it has this explain the impact of rising interest rate on economic stocks. We can change also. It will analyze, it will create a concepts and generate the economic report and save the result, print the result. Okay, this is the task of this main functions. Okay, and if I go to this, there are three things: graph, nodes, and state. As we are working on this land graph, what was there? Nodes was there, edges was there, okay, and there was some relationship was there, okay. So this graph is the orchestrator. Let's go to the nodes, okay. So if you go with the nodes, let's go here, okay. So this LangChain Groq, if you see in this requirement.txt, LangChain Groq, and go to this graph, sorry, which one? Nodes.py. This is coming from requirement.txt. And there is a tool. So this is importing two tools, and in which there are different tools calling within this tool. One will fetch the inflations, other will fetch the interest rate, other will fetch the wiki concepts, other will fetch the technology market snapshots. So these are the four tools working, okay, within the tool. And the LLM we are using is Groq LLM, and the model we are using, you can say right now as LLM, is Llama. Okay. So whatever informations we are passing has one definitions. This is a, we are defining it, one function. Okay. So this is a resolve concept. What is a resolve concept? It will take up our input. It will take up our prompt. So whenever you see a resolve, it is again a one node. So LLM, whatever we are passing in the chat GPT, let's say, if you are giving some prompt, it is going to resolve concepts. Okay, if you see the prompt we have passed to this resolve node, okay, and this is storing all these concepts and everything. So it is returning what it will return? Concepts. Okay, and we have a second function because these all are the tools. Inflation, these all we will hold the information. So how much, how we are going to capture it? So get inflations, get interest rate, get knowledge. Okay, and we have this get response or something. Okay, get generate reports, and whatever report, how we are going to have the report, this is again LLM will work at. Generate report is LLM. So if you see this one chart, the report we are using is LLM, and the resolve using is LLM. Other, we are using the tools. Got it? Now where I was. So let me again go back. So this generate report here we are using LLM because again it is a summarizing things. So that is why this prompt is there. And this prompt will hold the information of these tools, and this resolve concepts, because it will also have this, our prompt, original prompt was economic concepts or something, right, to give us inflations and something was there, right. So it will come from here. So all these informations will go to this generate report. Okay, and then it is storing in LLM. That is why you are getting a report. So whenever this generate report will execute, it will return the report information, and report will hold all these things. It will hold concepts, inflation, interest rate, and technology market. Got it? And your response will be something like this, similar to this in point wise. Got it? Now we have something called state.py. State means again, kind of a database. We are trying to store it. So this is a dictionary form. Now the tools, which all tools we have used? Freight. If you see this freight one, that tools we have used. So this is the definition of tools, freight tools. So we are defining these tools here. Okay. And we are having the response. If you see what is it is returning. If you see it is returning some informations. So these are the informations they are returning. So parameter is ID API key. Okay, this is connecting and it is returning the informations. Okay, so what it will return? It will return the latest observations of freight series. It will return. Okay. Now if I go down and we are passing this as argument. Okay, here. If I go down, these all are the definitions. So freight tools will fetch inflations, interest rate, wiki informations is also there, and market snapshot is there. So it will have those
Excuse me, sir.
information. Yes.
Sir, didn't we perform the same thing in nodes.py file?
Notes
There
dot.
also we py file. There also we did tool calling.
Yeah, tools is coming from here. Okay. Nodes basically has all your you can say the tools. Yes, tools is there, but what all the nodes means this all these things are there in nodes.py all, but in tools we have only these three things. Got it?
Okay, sir.
Okay. So nodes and tools. Nodes will hold all the touch point. For example, we have a two LLM you are using at input and output, and there are three tools. Okay. As tools has this API, if you see these tools, okay, 1 minute. If you go this, there is a resolve. Okay, this is LLM, and the inflations, everything we are calling from the tool. Okay, we are calling from the tool. If you see this one, tool, module, and tool
Yes,
is
sir.
this. Got it? Got it? This one.
Yes, sir.
So these are the two separate things. Okay, we are calling in that one. So tools, and there is something called graphs. So graphs will again add those nodes together because they are the supreme boss, I would say. Now they will give a directions. So that is why these nodes are there. So no, it will connect the nodes. Okay. So graph is responsible for. So it will have all these things. It will, you will see this state graph, start and it will connect the dot. If you see this one, how these graphs are being used for connecting the dots. Where I was. Yeah, if you see this one, graph is to connect the dots, connecting the dots. These are the graphs, basically, it is used. I think this was the diagram or some other diagram. Okay, it will connect the dots, okay, graphs. So for connecting the dots, we have this state graph. So this will add all the nodes. This will add all the edges together, make this graph compile, then it will run. Okay. So this is how we are going to stitch together all these nodes and edges together. Nodes and edges together, and it will make a graph. Okay. And then we are running it. State we have seen it, pi also, environment also. Everything we have seen it. And we have run it. Okay. Any questions, anybody?
Oh, excuse me, sir.
Hmm.
Sir, in this particular agent, we had already given it a query to answer.
Hmm.
What if
Hmm.
we had to take the query as an input from the user and then
Hmm.
make it answer? So, what all changes would be required then?
Changes where you have to in main.py, you have to go app.py, sorry. This is a hard coded one.
Yes, sir.
You can change it here. Okay. You have to make it a dynamic. Okay. So this is a hard coded one right now
So
because we are
how
not
to
using any UI. So that is why it is hard coded. Yeah.
how to make it dynamic? Like,
So make it a dynamic, like you have to use this input. You don't need to put this here. Okay. So if you see this query equal to this one or this one, okay. If I remove this one, it will have this query from the user. This is how you can make it a dynamic one.
All right, sir.
It is
Okay.
written or, okay?
Okay, sir.
So as we'll work on the UI, at that time we can remove it. Otherwise, if you can remove it, also it will work because it is capturing this, it will take the query. So these things we are passing here and it is joining system.args and these variables, okay? So this we can do it, okay?
Okay, sir.
And yeah. Yeah. So now you are able to see this, what we have used, this tool and the LLM that we have seen, okay? So this is again the state that I have explained to you, that the memory part is there. So right now we don't have the memory part here, but again, this is how we typically shared or store, in the state.py. It captures this concept at at this macro level. Okay. So whenever you see any memory implemented in a LangGraph, you'll see like this. So it is like a class and it is a type dictionary it is importing from. Okay. Now we have a graph wiring. Why we need a graph wiring? Because if you have a nodes and edges, and if you keep open those nodes and edges together, it will not work. So that is why we're stitching together. So then it will have the flow, right? So those nodes and these edges, we are stitching. And then this build.compile, whenever you write this build dot or whatever x.compile, then it will run the entire graph. So this line will execute nodes and edges. And what it will return? Resolve inflation rates knowledge report, resolve inflation rates knowledge and reports. Okay, the both things, nodes and edges, and has some this stake graph and a start and end. These classes would be there. Okay. Now we have tool calling. So as I have already explained, so this tool will return this CPI and this Fed funds. Okay, federal funds. Two things it will return. And this is the structure or say the definition of this function, Fred series. This is one function. It will fetch inflation information and the interest rate. Okay, it will return. What it will return? CPI and federal fund information. Two informations. This tool will help us because LLM alone is not sufficient to give us a response. That is why we have supplemented this tool informations, kind of a federal data informations, and we are looking for the recent data of consumer price index and federal funds time series data. The both we are passing to our LLM to decide to create our reports. Okay. Now we have knowledge nodes plus technical snapshots. This is again a tools extracting some information from some Wikipedia. Okay, and these are some market snapshots. So typically you'll see XLS, AP, MSFT. So these are some stocks informations that typically we have. NVIDIA, Microsoft, Apple. So these are the stocks informations that we are getting. And we are calling this function as technology market snapshots. Okay, and storing in the lines. Okay. Now we have something called how report we are generating. So whenever you generate any report, so this is the function, generate report is a function, and this will use what? LLM. This is again a node. We'll use this LLM. And whenever you see any LLM part, you'll see again a prompt. This is the entire prompt structure. So as a prompt engineering, you have been asked to change. So where you will go and change in the file? Will go in the change where this prompt is defined here. You must know that the where I have to change. Okay. So this report will have a summary of inflations, rates, and technology market, kind of a snapshots. And in report, it will return a report. So this function and whatever report it is returning, now we want a human-like response. That is why LLM.invoke is there. Got it? And dot content is there. If you remove it, it will not print. we are passing the entire prompt here. And whatever we are prompt passing, we are getting a report back, like a human-like response. That is why this function is returning a report. LLM.invoke is more important and passing this parameter, this variable prompt to invoke. Okay. So this is what we are able to execute this uh, use case. Let's clear all my drawings. If I can do that, okay. 1 minute, can I go down? Yeah. So what you have to do, I'll share the code. You have to do this first. I know these methods are there. Install requirement.text, have this environment variable. So change it. Don't use my API key. Run it app.py, you'll get the result back. Okay. So what you have to do, you people, once I share this file in the dot environmental variable, create your own Groq API key and Fred API key and change it. Got it? Okay. And also,
Yes,
these are
sir.
the key takeaways. Just read it out. Okay. So let's have 15 minutes breaks and then we'll come back. Is it okay for everyone? We have two more use cases. We'll discuss it. Okay. So let's have fair. Yeah, hello. Everybody's back. Is everybody back? So let me
Yes,
share
sir.
this. Yeah, let me share my screen. What I was just trying to. Okay. Fine. So it was where I was. So, fine. So it was. Yeah. Let me quickly share my screen and then we'll also see a few of the use cases. Okay. So okay. Just confirm if my screen is visible to you people. Okay. Is it?
Yes, sir.
Yeah, okay, thank you for confirming. So the third the use case will work on is the multi-agent systems, a supervisor agent that will divide the task to three specialists. Okay. So for example, if you're asking our agent that 50,000, where to invest. For example, if you have 50,000 for 5 years and we are asking this agent where to invest. So this is what the use case we will be working on. Okay. So what problem we are solving? That voice needs many lenses. Okay. So advice, whenever someone gives you, advice again, they also look at the different lenses, right? So concept, market data, and current sentiment we will look for in this problem, in this use case. The things we are solving is the advice we are giving, but how we are giving the advice, right? So market data, current sentiment we are gathering. And if single prompt false, so there is a no parallelism. If there is a no parallelism, right? For example, as we are seeing, the LangGraph will handle this complex workflows, complex concepts. So this is what we are trying to solve. Okay, and goal is to coordinate all those tools, all those agents, because we have multiple agents now, right? And who all gonna use this? Investors, retail investors. Okay, so those just want to diversify their funds and all that. So these are the people who will use our systems. What we are going to answer it through this agentic systems is, for example, if you're asking, I have this 50,000 for 5 years, let's say consecutively, you're trying to invest 50,000. So where should I invest in which all portfolios, right? So supervisor agent will plan the task. Okay. Specialist will have those research from the market data and will also gather some sentiment. For example, you cannot invest in the HDFC. Let's say if their stocks, degrading, then how you gonna, investing, right? So there will be also some of the advisor agent. Okay. So this advisor agent will merge all these three and allocate those funds and everything, right? And the output, what we are going to have is some of the per bucket reasonings, some of the horizon match risk note, the table allocations and everything, right? So if you see this architecture or topology, I would say we have three agents now. And on top of that, we have advisor and the supervisor and then advisor. Okay. So the Wikipedia, market, and the news, these are the three tools the supervisor will use. Once we have this, then you have this advisors. Okay. Again, the architecture we follow looks similar. So if you see this one, the architecture one. So for this architecture, let's say the question that we are asking is, let's say I have 50,000 and I just want to invest it for 5 years consecutively. So, I mean, it's again looking at the budget horizon, and the horizon is the number of years you want to invest in. The goal is to which stock, I should invest in. The budget is 50,000. So the first query, you will pass it to supervisor agent. Supervisor agent is nothing but it's LLM again. So LLM will plan. And when you say this budget, horizon, and goal, because your prompt is gets divided into budget, horizon, and goal. So this LLM, supervisor LLM, will divide the task. So who gonna handle this budget? Who gonna handle this time? And who gonna handle this goal, right? So they will delegate this task, means planning it. Who will do it? The LLM. And the LLM, who we have assigned it to supervisor agent. So supervisor agent will look for the market data and news data for the sentiments, and also the research agent. So three agent they will bring in to do this task. Okay. So researcher agent will scrap data from the Wikipedia. Market agent will scrap data from Yahoo Finance. And sentiment, for sentiment, we have this news API. And once you have all these data, then we need another LLM, because the which all data are coming from these tools plus LLM. At the output stage, we need that to be synthesized. Then only we will understand that, what we have to invest in, where we have to invest in. For these 5 years, if I have 50,000, so advisor agent will come into play. Will bring in those advice back, the synthesized informations coming from these all three agents. Okay. And they will let you know that the where you have to invest in, if you have this money coming or want to invest in for 5 years, 50,000 consecutively. Okay. Now the tool again, what all tools we are using: research, market, and news. These are again agent. So in terms of, uh, and I would say in terms of LangGraph, it is again a node, right? So these tools are responsible to execute this task. So if you see this Yahoo Finance, so this will bring your market information like a Nifty, S&P, gold momentum, and everything. And the research part, the tool involved with the Wikipedia, they will explain the index and data issue or something. Also, you have this advisor and supervisor. So again, these are the two. So whatever informations coming from the tool calling, they gather it, they summarize it. So supervisor and advisor. Supervisor will delegate the task once you have put in the prompt at first place, and advisor will aggregate the informations of supervisor plus research agent plus market agent plus news agent at the end. And it will go as a output to advisor agent to the LLM. And then they will decide these fund allocations and everything and put some their logic rationally. Got it? So these are the responsibilities. Okay. So let me,
Excuse me, sir.
yes, yes, please.
What is the meaning of fan out and fan in?
Fan out and fan in. If you go here, where was this? Supervisor fans out to three workers. Okay. So it will delegate the task, means assigning the task to three agents. So here we have researcher agent, market agent, and news agent. So how supervisor is going to decide? So they are fanning out, dividing the task concurrently. Means at the same time, supervisor agent will say to these three agents that, researcher agent, go and research the Wikipedia. Market agent, collect the information of Yahoo Finance, and news API will say the sentiment. So all those three agents will work parallelly, and fanning out means delegating the task to these three agents. Got it?
Yes, sir.
Okay. So this is how this will do. And there is something called fanning. So they will wait for all the informations. Fanning means they will, because they are waiting, because once these agents will have information, then advisor will work. So they will wait. So it's a fanning, waiting for the three before this synthesizing. They will wait, because advisor is the someone who will summarize the informations coming from supervisor, researcher agent, market agent, and news agent. So they are fanning in, but fan out is delegating the task to these agents and let them work concurrently. Concurrently means at the same time all three will work parallelly. Okay. Now where I was. Yeah. Okay. I think you can't see my screen, right?
No, sir.
One minute. Let me share my entire. Okay. For now, let me share it. Okay. Is my entire screen is visible or no, right?
Sir, it's visible.
No, what is visible? I mean, it's a command prompt is visible or not? Command prompt? No, right? 1 minute, 1 minute.
Excuse me, sir.
Yes, yes.
So, like in all the agents that we have built till now, we have only used a single API for one particular purpose. But
A
what if,
single API. When you say single API, what do you mean?
so like for example, for getting news, I'm only using one news API.
Mm-hmm.
So what if I want to attach another API just for like, I mean, if the first API doesn't work, then the second API can give me the information.
Yeah, you can use multiple API. Okay. For example, I'm using this news API. It is a free one. I can have multiple APIs and in the main or app.py, okay, we'll say that if this API doesn't work, use that one. Like if and else we will use. Because right now I am struggling. Why? Because there is some limitation of the API keys. Okay, so that is a possible, and you can treat every news as a news API as an one of the tool. So better do one thing: have those you create them as an agent. Okay, separate agent. This is the one way, or you just want not. I will use the news okay APIs in my applications. If one of the API key gets exhausted, I will use another news APIs. So that is a possible. Okay. Once the API of let's say news API is exhausted, let's say I'll use NDTV API key. Let's say okay news. Okay. So it will check and at the runtime it will check. If it is exhausted, it will switch to NDTV API key. Okay. Possible.
Okay, so like you were telling to build a different agent. So how will I do that? Like I didn't understand that part.
I didn't get you. Can you come again?
So when I sir, initially you told me that one of the way to do this was to build a different agent only for that purpose, like
Mm,
for using different API keys.
I think I didn't get you. I mean, can you just again explain me what you are trying to say? What I told you in that
Sir, what are the various ways in which we I can use multiple API keys
multiple API keys
for the same purpose? Like
for the
if
same
I'm
multiple. For example, what I understood from your question, don't use this word called multiple API keys because there are two things for the API key I'm using. If you see this one, and then I think then try to use things which I just wanted you to use. 1 minute, wait. Let me just scroll down a bit. Yeah, can you see? This is also an API key, and this is also an API key. Got it?
yes, sir.
So this API key I will use as a tool. I will make this new API. I'll tell it as a tool. But I'll call this as LLM. This is again an API key. So in the applications, let's say this news API key, there are 5 vendors who are providing me the real-time information, let's say of news. So are you saying that can I use those 5 news agencies API key? What you are trying to say?
Yes, sir. I want to use more API keys than rather than using only one, because what if the one API key that I'm using gets exhausted?
Oh,
So I
okay, I got it. Possible. That is a possible. That is a possible. You in this wherever I am calling this API key, na. So if you go where, uh, there is a tools, right? If you go here, tools, right? Tools. You can use if and else loop here. Here. Okay. This is the tool calling here. And I'm using the key, right? Dot environmental variable, whatever my key was there. I'm assigning it here. Okay, got it?
Yes, sir.
You can have two functions here. I'm using wiki explain and coming from those news API it is. So I have this one definitions functions, another I will define it here. Got it? Multiple definitions. And I'll see in the app.py if it one exhaust, use this one, this function. It's
Okay,
simple.
sir.
Okay, it's just not like that. Okay. So that is why first, whenever you say API, be sure of, because one is LLM, other one is tool. Divide
Okay.
it always. But both are tool.
Yes,
But
sir.
within your mind, try to segregate it LLM plus tool. Because LLM will give you a human-like response. Okay, that is very.
Okay, sir.
Okay, so let me quickly Python minus M, right? Virtual environment. Is it created or what? Dot activate. Let's activate it. Okay.
So
Python.
what if we want to fetch the news from two different websites? Then
Two
what?
different websites.
Yes, sir.
News. News APIs are basically I don't know from where they are fetching the informations because it is again a APIs. These organizations have built in for ready to use consumption purpose. So you have to check it from where they are using it. But if you want to use from different websites, use this wave scraping. Got it? Wave tool, wave search tool. Got it?
Okay, sir.
Hmm. So there are different way. Wave
So
search.
then there'll be, for
Hmm.
example, I want to fetch the news from two different websites. Then two different tools will be created, right?
You have to see that whether those two tools are navigating you to that website or not. Okay, so it is again an API. You have to see that the information which are coming are from these two websites or not, because the API providers are the one we have to depend on. We cannot do
Yes, sir.
anything. That is the restrictions here for the tool calling. Okay, but if you want a specific news, have those wave search tool enabled, you'll have those. Yeah. Now just see this one. I have run it. Okay. Quickly where I was. Sometime I get confused. One minute. So the question was, we wanted some advice on I have 50,000 and I want to invest it for 5 years. Where should I invest? This is the questions. Okay, hard coded one. And lastly, we got supervisor plan. This is the last agent. This is a fan out. Got it? The one they were saying. Okay? Rationalize and everything. If you see this one now, let me go. So supervisor agent, supervisor agent was, this is the prompt. And this prompt goes to supervisor agent. This is a fanning out. Fanning out means this guy will divide the task. As there are 50,000, 5 years, and some of the stocks to invest in. So that is the goal. Three tasks was there. So what they have done, the supervisor agent is very smart. They have delegated the task parallelly. They told researcher agent to do these tasks, market agent to do these tasks, and news agent to do these tasks parallelly. These guys are working parallelly. And this research agent and everything, they have collected this information and everything. You see, market agent, news agent, everything they have collected. Okay, from those API that we have seen. And this is the advisor guy. The last, what he is trying to do is fanning in, summarizing everything coming from those three agent plus supervisor agent. Got it? And then this guy is summarizing it. What they have summarized? This guy is giving us the recommendations. Based on the provided reports, I recommend the following diversified allocations of the budget and the 5 years time horizon. Time horizon is for 5 years. What they are trying to say, invest in index fund 60%, whatever amount you have. In debt fund, invest only 30%. And the gold only invest 10%. They're just trying to diversify their 50,000 amount. And they are giving us a rationale why they are saying to invest 50% in index fund is because diversified portfolio with potential for a large term growth suitable for 5 years time horizons. If you keep it 60% of our amount in the index fund will have, I mean, growth will have, uh, you know, uh, money which are, I mean, you'll get a lot of money, right? That is how you can interpret it. Okay, you'll have a lot of returning. Okay, debt fund only 30%. Why? Because have a low risk and regular income. If you want to have some money every month, so put in 30% so that you can have the expenses of day-to-day life. Okay, and it's kind of a hedge fund, right? More volatile or something. So only put 10%. Okay. And the risk is also they are seeing a risk with a 5 year horizon. The user can afford to take some level of risk, but moderate allocations of debt funds and a small allocations of gold ETF help to mitigate potential losses or something. So they are also giving you some warnings or something, but also they are saying this is not a financial advisor or something. So also consult with the financial advisor. It's like AI generated solutions we are getting it. Got it? Any question? The similar way, we have this app.py. Okay, just run it. That is why you'll see the similar coding. So we'll have a lot of practice. Okay. So we are getting supervisor plan. How many agents are working? Supervisor, researcher, market agent, news agent, and then aggregator agent. We have this graphs.py. I mean, okay, first go with tools.py. Tools, whatever tools we have, the news API, one of the tools was there. So we have defined it. Similar way earlier, what I have shown. Okay. Then state.py. This is again for the memory part. Agents, whatever agents we are calling. Okay. So these are the agents. So for example, supervisor agent. So delegating the task for the supervisor agent and the prompt is there. Similar thing is there. Then we have this research agent, market agent, news agent, advisor agent. Okay, and the return. So there are two prompts here at advisor agent level, aggregator level. And if you see at this level, supervisor level, but also to extract the information, you will say the prompting part is there to interact with this agent. Okay, and why we are giving this prompt? Because the information we are passing to LLM. That is why you will see this prompt. Okay, because ultimately we have to store it in LLM. You have to pass all these informations to LLM. And this research agent will return this research. And whatever they are researching will go to this LLM. And then the response we are getting. So finally, it will pass through all the LLM. Even the market agent information will go to LLM and is stored in this market. Finally, if you see this advisor agent last, so a research agent, market agent, news agent, all these information are captured because all the information passed to the LLM and then it is giving us a recommendations. And again, whatever recommendation we are getting is passing through LLM, then we are getting these recommendations. Before that, we are not getting. Just remember that. That is why this LLM.invoke is there. And these all prompts are passing to this one. And the output we are storing in this recommendations. That is why once you run this advisor agent, at last, will get this return. It will return these recommendations passing from this LLM. Got it? So this is how we see this agent working. Can you see my PPT? Can you see my PPT?
Yes, sir.
Okay, so these agents, we have seen all these three agents, okay? And we have also explained you this. So we have worked on 3 projects. Got it? 3 projects we have worked. So even this code I have explained, I'll share you this code so that it will help you, okay? So this PPT plus code. So try to run it, change the API keys. So you'll have a practice at least. And then you work on few of the complex problem, okay? If you feel like working on some of the use cases, okay? So this will help you a lot. Okay? So quickly, Let me stop sharing my screen. There is few things which are very interesting. So let me just pull out that PPT. Okay, we have some 30 minutes. So let's use it where I was. So this, okay, let me cross it. This one. Yeah. Can you see my screen?
Yes, sir.
Yeah, so in this 30 minutes, let me cover one more small topic, but very interesting. So we will talk about something called MCP, which is called Model Context Protocol, and try to, well, I'll explain this use case. So, I mean, it's a data assistant, and we are using this LangGraph only. There is something, the MCP that you are using, Alpha Vantage MCP. This is again a tool, okay, one of the external tool that we connect to, right? So, as we have seen that how we are going to use this tool calling and how we are going to integrate tools to our applications, our agentic applications. So similar way, how we going to integrate MCP, right? So there is also one of the LLM that I was going through. I have seen this Cerebras, this LLM. We'll see that this is a newer one. Okay. So we'll see that how this MCP we can leverage, because then we'll have end-to-end land graph part covered, right? So now let me go to this MCP. So when we say MCP, MCP means what, right? For example, once I say MCP, it's called Model Context Protocol. Okay, so let's say you have some of the AI applications, right? But as our applications, for example, think of this AI application which are here is one of the, I would say, for example, Chat GPT. Let's say it's a Chat GPT, okay? But Chat GPT doesn't have information of, let's say, database. Let's say if there are some particular database I just want to interact with, let's say, do they have a database accessibility of Air India? No, they don't have. They need MCP server. The web APIs, you need MCP servers, the Teams APIs, the local file systems. Let's say you have created AI agents who wants to interact with your, the Google Drive. Not possible unless and until you give them this MCP server access to. The same thing with the GitHub or local file systems again, right? So, I mean, we will see that how we can use this MCP servers. Similar way we use this tool calling, right? Can I move this? So how typically a model context protocol looks like, right? For example, in the left side, if you see there are something called AI models and agents. So what all are the AI models? Can anybody tell? इसमें एजेंट्स कौन सा है और एआई मॉडल कौन सा, कोई बता सकते हो लेफ्ट साइड में? इसमें इतना दिमाग क्या लगाना है? Right. So these are the AI models and these are the framework, right? So whenever you see agent, these are all are the framework agents, right? And let's say this agents, let's say this OpenAI or Claude wants to interact with Slack, Gendex, Snowflake, Dropbox, Google Drive, right? A GitHub. Will they? No. They need a separate APIs. If let's say Claude wants to connect with all those things on the right side, they need a separate API and the format would be different. That would not be the structure format. So when it comes to model context protocol, they have modularized the APIs. They have standardized the APIs. So even the same MCP server of Slack can be used by OpenAI, Claude, DeepSeek. CrewAI can use the same LangGraph, Chain, Index, or Copilot Kit, right? So the beauty of this MCP is that they have standardized the API calling so that everybody can use it. They don't need to work on the different structure and format of the API. Earlier, we had a different structure and format of the APIs. Okay, so that is why we need this. The reason people are working on this MCP servers. Okay, so now if I go down before MCP server, how it looks like. Let's say Claude, Gemini, and GPT-4. There are the three LLM. If they wanted to have the information of Slack, GitHub, or let's say Google Drive, they had a different API structure. So they needed a different structure and format of these API. If you see the Claude, there are three, four things they are calling. So it means the format of the API is totally different. But when it comes to MCP, they have this unique APIs. The one API is one MCP, a server can be used in a similar fashion by the Claude, Gemini, and GPT-4. They have standardized it. That is why you call it, they have made it a very unique. Okay, so this is the beauty of these MCPs. Okay, the same thing if you see with this, whenever you work on agentic AI or AI agentic use case, this MCP will come into picture because the tool things that we have seen, tool calling and everything. But the similar way, people will say that I have MCP server. Can you integrate it with the existing applications? Now you can say, yes, I can, because I know how to integrate this MCP server to the systems, right? The same thing, right now, we'll use this MCP servers, okay? And again, we'll work on this use case right now. So, what we are trying to achieve. So in this conversational agent, we can say this agent, we have this crypto fundamental questions like calling alpha vantage. This is again a tool. Now this tool can be called using this MCP. So I'll show that how we can call it through alpha vantage tool using this MCP. Okay. And you'll see that how we can use it. Earlier, we used to use this tool only. Okay. Different news API, research API, or anything, right? So the older way was what? The older way, what we used to do, so API calling, like REST client calling, they had this different request schema, tool wrapper was there. Okay. But MCP, what MCP changes is that they exposes this MCP exposes the whole API as a standard tool catalog so that agent can run it at a runtime, right? So I will be using in this use case Alpha Vantage MCP. It's a hosted server, and where it is hosted, alpha.vintage.co. Okay, and what it will return. So once you integrate with your use case, it will have the information of time series, fundamentals, FX, cryptos, indicators, and news sentiment also. Okay, and this is LLM. For example, the Groq, earlier we were using this Groq LLM. Now I have searched it and I got it this Cerebras, this LLM we will use. Okay. So it will help us to whatever we are getting from those MCPs tools and everything will pass the information to LLM. So whenever you design any of the systems, agentic systems, we need one LLM. LLM will be there. Okay. And to supplement those information, we need either MCP or tool, right? So now, what is MCP? As I already explained, it's an open standard and created by Anthropic for connecting AI applications to external tools. If you see this one, it is saying AI connecting AI application to external tools and data. So MCP servers has this tool calling facilities and have this data. That is why we want to more rely on this MCP, and it's very modularized and standardized. Okay. For example, USB-C for AI. There is a port, right? So one uniform interface replaces N spoke integrations if they have this different N numbers of bespoke. MCP makes it compatible, connect with any models, and they use these MCP servers. So servers, earlier there were three primitive servers. Some of the dynamic discovery was there, transports. Okay. So why it matters is this is the important thing. They have this standard tool schema. That's all. That is why we need this MCP. Because this MCP has a standard tool schema. Okay. And no custom parsing for the APIs. Only a standard schema they use it. Okay. So now let me clear all the drawings, cross it. Let me go down.
Excuse me, sir.
Yes,
So can
please.
you again explain USB-C?
थोड़ा जोर से बोलो आप, आवाज ही नहीं आ रहा मुझे।
So can you explain USB-C?
This one. This is nothing. This is just a port, USB cable. So MCP is like USB-C cable that we can use it for any charger, right?
Oh, okay, sir. Okay.
It is like that. Okay, don't
Okay.
get confused. It's just analogous. Okay. So now MCP architecture, just we see. So there is something called client and server in uh, whenever you see MCP architecture, it looks like client and server. So the host is that in the applications, for example, like ChatGPT wants to interact with the external APIs and tool, then they look for the MCP servers. So here this host would be our LLM. So that we call as client. Client means where we are on which interface we are trying to interact. And the server, if you see this is the right part of server. This one. This is our client LLM, and this is a servers. Okay. So this LLM server will let you connect with this data source or APIs. Right now, I'm connecting with Alpha Vantage data source. May have possibly in the future, I'll connect with database, files, or other services through this MCP server only because it is a modularized and standardized. And this is server side and this is a client side. That's all. Okay. Now where I'm cross it. So use cases is that what this MCP, once I connect with this MCP, what it will give us. Live codes informations, it will give us fundamentals, market status, crypto and FX is something, it will give us news sentiment, some of the technicals it will give us. Okay. Architecture is that I have some prompt. Prompt will use this reactive agent. It's something called loop. You might have heard of something called loop engineering, graph loop. It will check first logics and everything, whatever we are giving this prompt. App.py will run it. We have this prompt there, and it will take prompt to React agent. LangGraph will activate, and this will go to this Cerebras LLM. This is one of the LLM, and it will have this query, and it will fetch this client information as well, delegating the task. And we know that we have integrated this Alpha Vantage MCPs. And this MCP has how many numbers of tools? 126 tools. Okay, we can also explore it. Okay, so this is how it will works. It will make our life easy. Okay, so let me go to this code part where can you see my screen? No, right? 1 minute. MCP1. Just give me 30 seconds where I was. CD told me right now. Just copy paste. Control C. CD and then D, right? Code and dot. Share my screen. Can you see my screen?
Yes, sir.
Okay, just give me 30 seconds and then again I'll share my screen. Uh, just 30 seconds. Okay. And then start by, let me check if, Mhm. Let me share my screen. Okay. Yeah, can you see my screen? Okay. Is my screen visible, right?
Yes.
So here, again, we have, if you go here, okay. So we have one folder, market agent, okay. Inside this, there is a init file, okay. And in this init file, there is a nothing. It is only saying market agent, a LangGraph React agent over the alpha vintage MCP server plus Groq or something like this they have written, okay. But if you see this one, why we are writing this init, we are making a module, a package. That is why this init.py is there. It's a constructor. If you this agent.py, so we are having one agent, okay. So in this one, we are using some of these tools. So let me go to this requirement.txt file. So these files, you know that LangChain one, LangGraph one, okay. This LangChain core framework. We have this Cerebras. This one is LLM, and this is MCP. Okay, so that is why we are passing it, and this is for environmental variable capturing. Now let me go to the environmental variable. What all I'm using? I'm using alpha vintage API key. So let me give you this to you. Chat. If you go, okay, alpha vintage, cross it. From there, I have obtained this API keys and this MCP servers. So let me again stop share my screen. Let me share my screen entire. So if you see this one alpha vintage, okay. So this alpha vintage has this API key. You just click it this. What it will give us a stock market data for APIs and give us this grounding response. So you have to just click it here. And also it gives us seamless MCP support for AI. Okay. So just hit it and you get this API. Okay. Let me again go back to my dot environmental variable. And again, I have got this API keys. And in place of Groq, I'm using this LLM. So again, I will go to this control C. Let me share you this URL as well. It's control V. Just mute yourself. Priyansi, just mute yourself. So it's a one of the LLM platform. The way can anybody remove? Okay. So this is the key that you will get. Just have this API key from here. Okay. So this will give you this API key. Okay. So if you go down, you have analytics and everything. Okay. If you have this playground, you can ask questions. Okay. So this will work. Okay. This is how we get the API keys and everything. Okay. Now let me go to this MCP one. Now you know that. Anybody can remove. Nobody there. Okay. So this is the API key and everything that we have used for MCP. Now go to app.py first. This is the first starting point for us file. Okay. So let me just run it for you people, and then we'll explain, right? Okay. So now, once you run it, let it run. This is our entry point. Okay. So we have this variable importing from this future module. Okay. Async, because we have some asynchronous task. Means we have some of the module will work parallelly. And then just go down. Okay. We have this LangGraph agent and this banner. Okay. This is kind of a prompt. Okay. and we want some final answers. Final answers means coming from the MCPs, because we only activated this MCP. This is again a functions. So what we are saying here in this banner, this is again a prompt. Okay. To do all these things, that we will pass it as a informations. This is not used here, but at a runtime, whatever we want to have, we want this market agent to do. These are the few related questions that we put in. So whenever you run it, it will have these things. It will prompt. Just see what they are saying. Latest code for AAPL. This is stock again. Compare daily performance. So this something like this. So let me just have this Tesla information or something. Let me copy it. Let me paste it. Let's check if it is working. Then it's okay. Okay. Otherwise, this is for this API key and all that. Okay. So once you run it, hit it, our code will start executing it. Okay. So these definitions again in the main will capture all the your informations. Okay. We have put in here these questions, and it will return if there is a no answer produced. Okay. Otherwise, it will go and invoke the agent. Async. There are two async. It will take a questions and tell the agent to work first. And there is one more definitions. Okay. Agent. It will activate this MCP servers. Okay. And then the banner one, the questions that I put in from the banner, it is working. Okay. And then if I go down, it will start the main functions. Okay. If it doesn't work, we'll change the API key. That's all. Okay. Now you just go to this. Okay. This is the API key issue. Okay. Got it. This is API key. So let me go to this vintage one. Let me stop sharing my screen. Let me again share my screen, entire screen. And let me change what it is saying. So it is saying high traffic. Okay. And that is why it is not running. One. Let me go and try to solve it. If you go up, what it is saying. Okay. So now the API key that we were talking about, this there press is okay, this new API. Get the API key. Let me directly hit it. And okay. Let's say I say as educator, organizations, let's say this one, email. Let me check it. If it's worked, then it's okay. Okay, get the free API key. If I write this one, I get this API key. Okay. So let me copy it. Let me copy it. Let me put it here. So in .env, let me go here. Okay. Let me go down and let me put it this. Okay. This is the API key I have for this. Okay. It's Control S. So let's double check, double sure it. Cross it, just go down and say CLS. And again, run this Python app.py. Let's wait. Okay. Now we were where we were in this agent.py. If you go here, so the agent that we have used was this alpha vintage one, right? Like a MCPs that we have defined it here. Let's say, let me put this one, latest code for this AAPL there. Let me put it. Okay. So it will run for you. Just grab the API keys. No issues. Okay. So this one is our tool calling. This is for agent. So here agent is the MCP, and MCP agent here we have used is alpha vintage. This one. and there is a configuration file. Whatever dot environmental variable carries, we typically create config file. So if you see this one, alpha vintage MCP servers, and it holds the information of this LLM. There are two things. We have storing and loading from dot environmental variables. So keys are in dot environmental. Anybody has any questions or what? Okay. So that is why this config file is there. And agent is defined in agent.py. Agent is servable, that one alpha vintage. Nothing more is there. And this is loading our MCP server. Okay. Then we have this app.py that we have seen it already. Okay. So this is how we are running it and getting the informations back. But if you see this one, MCP one, in the tool, we have a lot of, informations that we had to put in. But when it comes to MCP, you see the code is modularized. Small code now we have, right? So that is the beauty of this, the MCPs. It saves a lot of your coding bandwidth also, okay? So now if you see, I have put in this information, so AAPL, just can you code for this AAPL? So it is giving us an information, this Apple information. So this is the stock market information. It has opened at this dollar, high at this, low price, volume, previous change is this one. So this is the latest code and coming from 26/6/26. This is the current information. Got it? Everyone got it? So it is giving us a live information. So the MCP has given us a, one of the features they have activated, that it is also giving us a live information. That is the beauty of this. Okay, got it? So this, we have seen how we can integrate these MCP servers using this LangGraph and get the current informations. So this is also one of the way to create AI agent using LangGraph. So what we have understood in this entire sessions, previously 2-3 sessions, we are able to create AI agent, agentic AI tool calling and MCP servers using this LangGraph. So we have covered two framework. One is Crew AI, other one is LangGraph. Okay. Tomorrow we'll cover this semantic kernel. Got it? Anybody has any questions so far?
Excuse me, sir.
Yes.
Sir, right now you mentioned that the MCP is able to give us the current
Not
current
the current
data.
information. Here we have used this alpha vintage. It has ability to give us current information, stock price. Not
So
always.
can you explain alpha vantage? Like I didn't properly understand what it is used
Alpha
for.
vintage, can you see this screen?
Yes, sir.
No. Yeah. Alpha vintage uh, uh, is a platform. Through the API, they have current information. They fetch current information. And they give us the people, for example, to use the APIs that will give us the current information. Okay,
Okay, sir.
let me explain again. For example, there is a Amazon.com and they have 5 APIs. One is for if they roll out a new product, they have one APIs. They have some older product, for that they have one APIs. Now they have created one MCPs and they have told you that this is the URL, this is my MCP server. And if you hit this MCP server using this API key, you will get what all products which are coming in the near future, updated information you will get. The same thing happens with Alpha Vintage. It's just a platform, have those MCP servers. It's like again a APIs, holds this current information of the stocks. That is why you have got this information, current information. Can you see? This is the latest quote.
Yes, sir. Got it,
Got
sir.
it?
Yes,
So
sir.
it's not like MCP will always give you the current. There might be, I will have an MCP of data source. I will have an MCP of GitHub. They will work differently, but they are so modularized that it saves a lot of Python coding and everything. Okay, we'll have smaller code now. It looks like a smaller code. Earlier, when we were calling the tool through the API, we have a huge code to incorporate. So now you can say out there that I am able to integrate tools, and I can able to integrate these MCPs. I can able to integrate API keys in your resume, right? Got it?
Yes, sir.
So I will be sharing you this PPTs maybe at the end of the day today. Okay, I have some work. So if you have any questions, you can ask. Okay, any questions so far? Anybody? We will start semantic kernel tomorrow. Okay, let's close for today. Okay. So thank you so much. Thank you, everyone.